This is the video on how to calculate percent yield. As always, the things you're going to need is you're going to need a periodic table, and you will also need a calculator. I will be following this step by step from the packet. So let's just read the problem here. It says baking soda decomposes in heat according to this equation. So it gives us a nice little chemical equation there. It says if 25 grams of NaHCO3, let's underline that, decomposes in this reaction, how many grams of sodium hydroxide, so how many grams of sodium hydroxide, that's what we want to figure out, should be produced? Then there's a second part of this question. It says if 10.5 grams of sodium hydroxide is actually produced, what's my percent yield? We'll get to that part in a moment. But step number one is to calculate theoretical yield. And the way to do that is to do a gram to gram conversion. So if we're gonna do grams to grams, we're gonna start with this guy right here, 25 grams of NaHCO3. Okay, that's what we're starting with. So NaHCO3, this is our A. And then sodium hydroxide, which is NaOH, this is our B. That's what we want to find. So we're going to do grams A to grams B. And if you need help with this part, you can find the video in this playlist about multi-step conversions. So because we know it's grams A to grams B, just really quickly, I want to outline what that kind of looks like. So we're going to start with our grams of A. And there's no direct way to get to grams of B without converting to moles. So then we're gonna go moles of A to moles of B to grams of B. This is what we call like our conversion pathway, okay? And then in order to do each of these things, we're gonna find some sort of conversion factor. So here, to go from grams to moles, we're gonna need molar mass. To go from moles to moles, moles of A to moles of B, we need mole ratio. And to go from moles of B to grams of B, we're also going to need molar mass. So if you're like, well, how do I know which ones that I need for molar mass? If this is grams A to moles A, this is going to be your molar mass of your substance, whatever's A. Here, moles B to grams B, just like this. So let's start by finding our molar mass for these substances. So for the first one, our A, remember, is what we're starting with, is NaHCO3. And so I'm going to do this over here. We have NaHCO3. So we have Na, H, C, and O. Now the only one of these that we have more than one of is our oxygen, so we can go ahead and put that there. Then you're going to use your periodic table to find the values, the masses here. So oxygen I know is 16, carbon is 12.01, hydrogen is 1.01, and sodium, Na, is over here, and it is 22.99. Okay, and all of these are grams per mole, but I will wait until the end to do that. So 16 times 3 is 48. So now that we have that, we just add all of these together. So 22.99 plus 1.01 plus 12.01 plus 48 is equal to 84.01 grams per mole of NaHCO3. Now, we are going to need our molar mass for whatever our substance B is, which is sodium hydroxide, and sodium hydroxide is NaOH. So we will do that here, NaOH. And luckily, we have only one of each element. And also lucky is that we already have a lot of these over there. So this is 22.99. Oxygen is 16 and hydrogen is 1.01. So we're going to add all of that up together. 22.99 plus 16 plus 1.01. And this is equal to 40 even grams per mole. So now we have our conversion factors for there. So now what we're going to do is we're going to set up our conversion. So this is our little pathway to get where we're going. So let me grab another sheet of paper. And here's what we're gonna do. We're gonna set up our conversion right here. Okay, so now that we have our conversion factor and all of our stuff, we're gonna go from grams A. So we start with 25 grams of NaHCO3. That's what we start with. So to go from grams to moles, we're gonna need that molar mass. And look, grams is on the top here, which means the grams should be down on the bottom. So it is 84.01 grams of NaHCO3 in 1 mole of NaHCO3. Now, if you think that it's not worth your time to write your units and your chemicals, it is. So please do it, okay? So we just did that, grams to moles. We used the molar mass, okay? Now we're gonna go from moles A to moles B. And the way to do that is to use our balanced chemical equation. So lucky for us, this is already balanced up here. So all we have to do is look at the ratio, at the coefficient for each one. So over here, what we're gonna do, so if moles of NaHCO3 is on the top over here, moles of NaHCO3 will be here. And what we want to find, because if we're going moles A to moles B, is now we want moles of NaOH on the top, okay? Now, if you're like, well, what numbers do I put here? Look at the coefficients for each of these. So NaOH is right here, and there's no number written, which means that is a 1. And then NaHCO3 is right here. There's no number out front, so that means that is also a 1, okay? Now, last step we just did, so we now have the grams to moles of A and the moles A to moles B. And now we need to do mole B to grams of B. This is our last one. So what we're gonna do here is we are going to put, if you see moles of NaOH on the top over here, moles of NaOH down here, and that means that grams of NaOH will be at the top. So what do we put where? Well, grams, we're gonna use our molar mass, and then it is 40 grams in 1 mole. So now that we have this grams to grams conversion set up, we're going to do the math. The easiest way to do the math is to multiply everything on the top and then divide it by everything on the bottom. So we have 25 times 1 times 1 times 40. So 25 times 40, which is 1,000. So we've got 1,000 on the top, and then we have 84.01 times 1 times 1. So it's just divided by 84.01. We get this nice big number right here, so we're going to just leave it as 11.9 is our number answer, but we're missing a unit and we are missing a chemical. So 11.9, what of what? So here's how you can figure out. This right here is gonna be your unit and your chemical for your answer. So this would be grams of NaOH. So that's step number 1. I know it's a pretty big step, but you do a grams to gram conversion, which is what we did. Now, step number 2 is that we're going to take our actual yield and divide it by our theoretical yield. So this guy right here, the grams to grams conversion, this is your theoretical yield. It means in theory, that's what we should produce. Now in the problem, here's what it says. Let me slide this down for you so you can see it. If 10.5 grams of sodium hydroxide is actually produced, what is the percent yield? So here's the next step. Now that we have our theoretical yield, what we're going to do is this is step 2. It is actual yield divided by theoretical yield times 100. and that's how we do it. So our actual yield was given to us in the problem, and that was 10.5 grams of NaOH. That was our actual. Now we're going to divide it by our theoretical, which we already found was 11.9 grams of NaOH. And then we're going to multiply that answer by 100 to get a percentage. So here we go. It is, let's see, 10.5 divided by 11.9 times 100. We have 88.2%. And that is our percent yield.